Well, good evening everybody. In today's session, I'm providing the explanation for Theorem 10.4. Let's go through the statement and also along with that, we'll see the figure. What is to be mentioned in that, what is to be proved in that. The line drawn. According to Theorem 10.4, you see the statement, the line drawn through center of a circle. You can see this is the center of circle. The line drawn is OM of a circle to bisect the chord. Now the chord is AB and bisection breaks into two parts. Okay, so the statement says the line drawn to the center of the circle to bisect the chord is perpendicular, means this line makes an angle of 90 to the chord. So first of all we can see it's mentioned that what is given to us in the question? We are given a chord AB and also it is given, you see this mentioned here, to bisect the chord. It means the distance AM is equal to MB. AM is equal to MB. So this is given to us. And we have to prove that this line OM is perpendicular to the chord AB. So let's start the proof. We take two triangles. You can see two triangles here, OMA and OMB. We'll prove the congruency in that. Alright, so let's write in triangle OMA and triangle OMB. You can see the difference between these triangles, OMA to the left and OMB to the right. Alright, now let's do the congruency. If you see this distance from here till here and here till there, it is the radius. So measurement OA is equal to OB, and you can write here radii of circle. Alright, so radius is proved, right? Second, if you see this line at the center, from the center of the chord, this line is common for both the triangles. So you write OM is equal to OM, that is common. Well, now the third thing to be proved in that is already given. If you see here, the measurement of MA is equal to measurement of MB. MA is equal to MB. So mention that MA is equal to MB. So you write here, it is given. Where is it given? It's given here already. So we can see that these two triangles are congruent by S rule, and S rule. So after proving these three, right, we'll mention, therefore, triangle OMA is congruent to triangle OMB by which rule? SSS rule. After writing this, what else do we see? We will see that this angle OMB, the measurement of this angle is actually a linear pair. Look at this. If you join both these, it's a linear pair. Alright, so we'll mention the line. Hence angle OMA is equal to angle OMB by CPCT. Right, corresponding property of congruent triangles. But as we can see, the sum of these two angles makes a linear pair. Alright, so we'll add both. We'll write but angle OMA, as you can see here, OMA plus OMB is equal to 180 plus angle OMB is equal to 180. You can write here linear pair. Alright, so once it is done, and we also know that these two angles, the measurement of these two angles are equal. So you can replace. What is to be replaced? You can replace any one of these angles. I can write here OMA plus OMA, as these two are equal in measurement, is equal to 180. So it will give me twice angle OMA is equal to 180. Therefore, angle OMA is equal to 180 upon 2. Answer is 90. Now this angle proves that the line, which line? OM is perpendicular to AB. This is what we had to prove. So in the last line you write here OM is perpendicular to AB. So with this we enter the theorem.